In today's lesson, we're going to be discussing the properties of real numbers or properties of numbers. It says what you'll learn. Scan the text in this lesson. Write 2 facts you learned about properties of numbers as you scan the text. So if you look down here, we've got a big paragraph under vocabulary link. We are going to talk about identity properties. We're going to talk about inverse properties. So there's a whole lot of new things we're going to learn here. Hopefully some of this will be new and some of it will also be a review from last year. So we're not going to take the time to fill this out right now. We're just going to jump right into our lesson. Okay, vocabulary review. Define variable, the word variables in your own words. So variables, these are symbols, usually letters, that take the place of unknown numbers in algebra. And that should be a pretty familiar word to you. Okay. If we look down here, we've got some new vocabulary. It says fill in the blank with the correct term or phrase. So we've got all the different terms over here, and hopefully I can do this correctly this time. 2 numbers whose product is 1 are called multiplicative inverses or reciprocals. So for example, if you had 3/4 and its reciprocal 4/3, when you multiply fractions, you multiply straight across. So 3 times 4 is 12. 4 times 3 is 12, which simplifies to 1. So the product of reciprocals is always equal to 1. And a synonym for reciprocal is multiplicative inverse. So we used reciprocals. Expressions that represent the same number are equivalent expressions. So for example, 8 plus 1 and 10 minus 2 are equivalent expressions. They both represent, 10 minus 1. 8 plus 1 and 10 minus 1 are equivalent expressions. They both represent the number 9. Another equivalent expression would be 3 squared. 3 squared is also 9. So again, those are equivalent expressions. They're different names, all standing for the number 9. The number 1 is known as the multiplicative identity. Going down there a little bit, running out of room. So basically, the multiplicative identity, no matter what number you multiply by 1, it's going to keep its identity. It's not going to change. So for example, 10 times 1 is equal to 10. It doesn't change its identity. Similarly, the number 0 is known as the additive identity. So when you add 0 to any number, that number keeps its identity. So for example, 10 plus 0 is 10. We didn't change that 10. It was 10 on this side and it's 10 on this side. Vocabulary link. Identity is a word that is used in everyday English. Find the definition of identity using a dictionary. Explain how its English definition can help you understand its meaning in mathematics, specifically when referring to additive and multiplicative identities. Okay, so the word identity, and I'm not going to look this up, I'm just going to put the definition in my own words here. Identity, that is, your identity is who you are. So my identity is who I am. I'm a teacher. I am a female. I am a Virginia Tech Hokies fan. I am a mother to a beagle. So that's who I am. Okay? So to help us remember multiplicative identity and additive identity, we can think about, it keeps these numbers, it keeps their identity. They're not changing their identity, and I've said that multiple times. So multiplicative and additive, did I spell that right? Yep, additive identities allow numbers to stay the same or keep their identities. They don't change from one side of the equal sign to the other side. 10 stayed 10, 10 stayed 10. You could also use this with variables. So 1 times x is x times 1 is still x. It doesn't change. That's your multiplicative identity. Or 0 plus x equals x plus 0 equals x. That's your additive identity. X is the same here, here, and here. It's not changing its identity. Take a minute to fix my light here. It kind of fell off. Bear with me. There we go. All right. So over on to the next page, we have an example, and it says fill in the blanks with a property used in each step. So we're going to start going through some of the different properties. So we have a pretty large expression going on here, and the trick is when you're deciding which properties are being used, you have to look at what changes from this step to this step, and so on and so forth. Okay, so the first thing that we notice right here, we know that the 9 plus 3 became a 12, and we notice that the 9 minus 8 became a 1, and everything else is pretty much the same. So we didn't really use a property there. However, we did simplify the expression. So in some case like that, you would write simplify. You might also see combined like terms because the 9 and the 3 are constants and the 8 or the 9 and the minus 8 are constants. So you might also see combine like terms. And again, neither of those things are really properties, but they are steps when you're simplifying an expression. All right, if we go down to the next step, we kind of look for everything. Those 5 and 12 are the same. The 1 is the same. The 1 over 60 is the same. However, the negative 5 plus 5 has now changed to a 0. So you can kind of see that there's a change. This right here has now changed to a 0. And these in this example, it was nice. They kind of pointed that change out for you right here. So that's going to be the additive inverse property, the additive inverse property. So a number plus its opposite equals 0. That's your additive inverse property. All right, we go down to the next line and we notice that the 5 times 12 has now changed to a 60. So there's a change right there. And you can either underline it or circle it, whatever makes it stand out to you. And then everything else has pretty much stayed the same. So again, we didn't really use any properties here. This is another simplify step. We simplified the expression down. We didn't really use any properties. All right, looking down here to the next step, we notice that the 60 times 1, that 60 times 1 has now changed to just a 60. And again, that's been pointed out to you over here. 60 times 1 equals 60. And we already talked about this one over on the left-hand side of this page, that when you multiply a number by 1, it keeps its identity. So this is the multiplicative identity property, multiplicative identity property. All right, so then we're looking from this line to this line, and we notice that the 60 times 1 over 60 has now changed to just a 1. So we have a number times its reciprocal equals 1. So that's your multiplicative inverse property. So you can think about a number and its reciprocal. They're opposites or they're inverses. Opposite and inverse are synonyms, so that might help you remember that property. And then last but not least, if we look from this line down to this line, we notice that 1 plus 0 has changed to 1. So the property that's been used there is the additive identity property, because the 1 has kept its identity in this step, and this step it's not changed to another number. All right, moving on down, we have use the commutative and associative properties. The associative property, use the associative property to write two equivalent expressions. Use the numbers 4, 6, and 9. So the associative property means that your grouping changes. So your grouping changes. Okay? And to help us remember that, we can think of the root word associate. When you think of associate, who you associate with. Those are the people maybe that you sit with at lunch, or that if you can choose seats you would like to sit with in class. Those are your friends. You associate with them. They're your peer groups. So associate and grouping changes. Hopefully that'll help you remember the word associate. Okay, so we're trying to use 4, 6, and 9 to make the number 19. So we can use parentheses first around the 4 plus 6, and then add 9. So our order of operations here would say 4 plus 6 is 10, plus 9 equals 19. Okay. For associative property, we need to change what are being grouped together. So here 4 and 6 are best friends, but maybe they have a fight. And in our next example, we have 4 plus 6 plus 9, and now 6 plus 9 are best friends, and 4 is kind of on the outside looking in. So if we use our order of operations, we end up with 4 plus 15, which again equals 19. So we can see that it doesn't matter how you group the numbers together so long as they come out to be the same, and that will work every time for addition and for multiplication. Okay? Helping you remember, this is going to talk about commutative property. We haven't really discussed that yet. It says look up the meaning of the word commute in the dictionary. Find an everyday meaning that is close to the mathematical meaning and explain how it can help you to remember the mathematical meaning. So if we look up the word commute, we're going to find something along the lines of to change location. So your parents probably commute to work. I commute to work, right? I don't live in Gainesville, so I commute. I drive in. So we're commuting to change your location. So the commutative property, in the commutative property, the numbers change their locations. Okay, while the sum or product stays the same. So for example, 3 times 2 times 6 equals, well, order of operations, 3 times 2 is 6 times 6, right? So we have to do that first, and then 6 times 6 gives us 36. If I were to change the order of those numbers, so say I went 2 times 6 times 3, order of operations says I do 2 times 6 first, so that's 12 times 3, which is still 36. So there's a multiplication example. And again, it also works for addition. An associative property up here would also work for multiplication. They don't work for division or subtraction. So hopefully that either refreshes your memory or gives you a quick overview of some of the properties we're going to study. There are some more that we're going to talk about on our foldable that we're going to make later in the week. All right, have a good evening, folks, and I'll see you tomorrow in class.